Hey everyone, Chemistry Sensei here. Welcome to today's training mission. We are going to absolutely master the thermal decomposition of salts, so you can walk into your SPM exams feeling confident. Let's get started. But hey, before we dive in, remember, every great ninja needs a dojo to train in. You can sharpen your skills with a ton more practice questions over at the website on your screen, or just scan that QR code to grab the app. You know what they say, practice makes perfect.
So here's our training roadmap for today. We'll kick off with the main mission, then we'll learn how to decode color clues and identify mystery gases. After that, we'll tackle the calculations, and we'll finish up by looking at the common traps you need to avoid.
Okay, let's jump right in. The deal is, most salts break down, or decompose, when you heat them up. The key to absolutely crushing these questions isn't about memorizing 100 different equations. Nope. It's about becoming a chemical detective and learning how to spot the clues.
The official name for this is thermal decomposition. It sounds fancy, but all it really means is breaking down a compound using heat. So our mission is pretty simple. We're going to look at the evidence, like the color in the gas, to figure out what new substances are formed. Our first big clue is the residue. That's just the solid stuff that gets left behind after you're done heating. Think of this as the first signature at our chemical crime scene. It's a super powerful clue that helps us identify the metal ion, the cation, that was in the original salt.
Okay, this is your secret decoder ring. Seriously, copper is the easy one. It leaves behind a black powder, whether it's hot or cold. But here's the end exam trick you have to know, the difference between zinc and lead. Zinc oxide is yellow when it's hot, but it turns white when it cools down. Lead-2 oxide, on the other hand, is brown when hot and cools down to yellow. You have got to remember that color change.
All right, time for a quick drill. This is a real question from a past SPM paper. We've got a metal carbonate, we heat it, and the leftover stuff is brown when it's hot and yellow when it's cold. Go on, use your decoder ring from the last slide. Who's our culprit? What is metal X? Pause here and give it a shot.
Did you get it? The answer is lead. That specific color change from brown to yellow is the unique signature, the fingerprint of lead-2 oxide. See how that works? You recognize the pattern, you solve the problem. No need to guess.
Fantastic work on that first clue. But a good detective needs more than one piece of evidence. So now, let's hunt for our second signature, the gases that get released. This clue is our key to figuring out the other part of the salt, the anion.
These are the usual suspects right here. If the gas you collect makes lime water cloudy, you're dealing with a carbonate. See a nasty brown gas? Your brain should scream nitrate. If a glowing stick bursts back into flame, that's oxygen, which often comes along with nitrogen dioxide from nitrate salts. And if you smell that sharp, pungent ammonia, well, you've got an ammonium salt. These tests are absolutely essential.
Okay, another flash question. Fresh from a 2022 paper. You heat up some zinc nitrate and it makes a brown gas. I mean, come on. The name of the salt is a massive clue here. What's the gas?
And the answer is nitrogen dioxide. The word nitrate in the salt's name is the dead giveaway. The moment you see a nitrate salt being heated, you should expect to see that very distinct brown gas, NO2. All right, you've learned to read the clues like a pro. Now for the final skill, the one that sometimes makes students nervous, the calculations. But seriously, don't worry. I'm going to show you a super simple step-by-step method that works every single time. This is the ultimate technique.
So let's take a look at this classic exam question. They give you a nice balanced equation, they tell you the mass of the reactant, and they want you to find the volume of one of the gases produced. We're going to slice this problem up into 3 simple steps.
Here is our 3-step attack plan. It's always the same. 1, find the moles of the stuff you know. 2, use the ratio from the balanced equation to find the moles of the stuff you want to know. And 3, convert those moles into what the question asks for. In this case, volume. That's it.
Okay, let's do it. Step 1. Find the moles. The formula is just mass divided by molar mass. So we take our 18.9 grams divided by the molar mass of 189, and boom, we have exactly 0.1 moles of our zinc nitrate. Easy peasy. Now, for the most critical step, the one people always forget, the molar ratio. The balanced equation is our recipe. Those big numbers tell us that 2 moles of zinc nitrate make 4 moles of nitrogen dioxide, a 2-to-4 ratio. We can simplify that, right? It's just a 1-to-2 ratio. So if we started with 0.1 moles of reactant, we're going to produce double that amount of NO2, which is 0.2 moles. And we are on the home stretch. Step 3. Calculate the volume. We just take the moles of our gas, which we found was 0.2, and we multiply it by the molar volume, 22.4. And that gives us our final answer, 4.48 cubic decimeters. And that's how you do it. Mission complete. So you've learned the techniques, but just as important is learning defense. We need to know what the common traps are so we can see them coming and avoid losing easy marks in the exam.
This is what separates the novices from the experts. A novice will see one clue and just guess. An expert cross-references both the residue color and the gas produced to be sure. A novice completely forgets the molar ratio in the calculation. An expert knows that ratio is the entire key to the problem. And finally, a novice always mixes up the hot and cold colors for zinc and lead. An expert makes a flashcard or a funny mnemonic to lock that info in their brain. Don't fall into these traps.
So, if you remember one thing from today, let it be this. The real key to success isn't just about memorizing facts. It's about pattern recognition. Train yourself to see the clues, learn to recognize the patterns, and you will be able to solve any problem they throw at you.
And with that, your training for today is complete. You did an excellent job. But remember, the path of a master chemist never truly ends. So my question to you is, what's next? What other SPM chemistry topic are you ready to conquer? Keep that fire and that curiosity going.